Hey guys, what's up, people? Welcome to the session. How are you guys doing? I hope that all of you guys are doing good and taking care of yourself. And before we get started, guys, please ignore that sound. There's been a lot of construction work going on, some renovation work going on right above my place. So there's a lot of sound for the past couple of days. I know it's irritating, but what can we do? The world has to move on. So yeah, people, welcome to the session. My name is Anoop, and this is Vedantu. A very, very warm welcome to the Sprintex series of the last chapter of physics. By today, we would have completed the whole of Sprintex, guys. We have done some amazing questions in the past, so please check out all the Sprintex videos. Trust me, guys, it will definitely help you out. And I sincerely hope that your preparations are going good and you guys are giving your 100%. It's super important that you do. So today we'll be doing questions from radioactivity. I hope you guys are excited. Let's begin. Now, these are the topics that we'll be, these are the topics from which these questions are taken from: structure of atoms and nucleus, isotopes, isobars, and isotones, radioactivity, property of alpha, beta, and gamma particles, gamma radiation, uses of radioactivity, and sources of harmful radiation. So, all of these with harmful effects of radiation and safety precautions while using nuclear energy. All of these topics are what you have in this chapter. So we'll be solving questions from the previous year questions from based on whatever questions have been asked from this particular chapter. So we'll try to solve as many questions as possible, and more importantly, we'll try to do it in the least amount of time that we possibly can, right? So by this, guys, we have completed the whole of Sprintex. We have done all the chapters pertaining to ICSE 10th. So make sure that you check out all those Sprintex videos. Trust me, guys, you'll definitely find it helpful, before your exams. Trust me on that. This is your biology schedule. Ambika ma'am is taking a biology. You have another 2 more chapters to go for: nervous system and endocrine system. Chemistry is taken up by Anoop ma'am. Again, it will get over by 27th. Then we have English taken up by Shweta ma'am. Again, it will go until 27th. And SST taken up by Ankara ma'am. Again, it will go until 27th of Feb. Then we have maths taken up by Gopal sir. Again, going on till 26th of Feb. So today will be the last day where you will be getting the math video of probability to 6 p.m. So check out for that. Make sure that you subscribe to the channel. Make sure you hit the like button. Make sure that you hit the bell icon as well, because we have a lot of amazing content coming your way before your exams. So get ready for some amazing, fun-filled and knowledge-filled sessions. With that said, let's begin, people. Now, this was the question that I asked you in the previous session. Basically, we had done calorimetry chapter. This was a question that was asked in 2016 board exam that I gave you as a homework. The question was: state 2 factors upon which the heat absorbed by a body depends on. And the answer to this question is, first is definitely the temperature, and second, you can also talk about the material itself, because some materials, some materials would absorb more amount of heat, and whereas others, like insulators and all, would absorb lesser amount of heat. You can also talk about the mass as well, because greater the mass, then that could also affect. Greater the mass, then you have to give more amount of heat energy. So you can name any of the 3 factors. There are 3 factors. Out of these 3, name any of the 2 factors, right? So these are the homework rockers. We have Aditya, who was the fastest to answer. Congratulations, buddy. And it's Bhargavi in the second. Thanks a lot, Bhargavi, and beautifully done. Now, Anshika Jito, next level. She has explained the whole thing for 5-mark question itself. Alright, so yeah, she has written everything perfectly well. Absolutely wonderful. She has also mentioned the color of the body as well. Well done. And then Spandan as well. Specific heat capacity, temperature, mass. Absolutely wonderful. Keep up the good work, people. Keep up the good work. With that said, let's begin now. Radioactivity. Let's start. Right. Warm up a little. Let's begin. So 10 questions, not 10 questions, roughly about 8 questions. The 9th one would be a homework question. So yeah, 8 questions back to back, all from previous year question papers. We'll try to take the least amount of time possible to solve all these questions. So the first one is from a board exam 2017 boards. The question is a 2-mark question which was asked in 2017. 2 to 3 minutes in your exams. We'll try to do it in less than 1. The question is: state 2 characteristics of a good thermion emitter. State 2 characteristics of a good thermion emitter. The options are high melting point, low value of work function, low melting point, or high value of working or work function. So you have to mention any of the 2 characteristics, guys. I'm going to give you 5 seconds now for all those who want a little bit more time to think for every single question. Take your time, pause the video, aram se solve the question. No rush. but here we'll try to do it as soon as possible. But yes, in your while you're watching the video, all those who are watching it, who's watching it while it's being premiered, and all those who are watching the replay, does not matter. Pause the video, try to answer the question for yourself. How the answer, guys, it would be that you need a high melting point. Obviously, you don't want the metal to melt. That is one thing. And yes, it should have low value of work function. So what is work function? Is nothing but the amount of heat energy that you can say that the minimum amount of heat energy that is required, or minimum amount of energy that is supplied to a metal which to emit the electrons. So how much amount of heat energy that you have supplied to a metal in order to emit the electrons, that is what is called as work function. So if you have low work function, then you don't have to give in much energy, right? So that is a very good thing. That is a very good thing. So that is why that would be the right answer. Low value of work function and high melting point. Second question is a little bit more, not complicated, but it is a little bit more, what to say, a little more specific on it. It's a 2-mark question asked in 2016 board exams, a very important question. So the question is, an element S, Z is the atomic number, A is the mass number, decays to R, that is the element. The atomic number is 85 and the mass number is 222. After emitting 2 alpha particles and 1 beta particle, or it's not if, it's 1 beta particle, find the atomic number and atomic mass of the element. It's an amazing question. Trust me, you'd love this question. The question is this, guys. So there's an element given to you. It undergoes radioactive decay, and finally what you're going to get is basically this, which is R. 222 is the mass number, 85 is the atomic number. If that particular element, that is S, ZA, is emitting 2 alpha particles and 1 beta particle, what would be the atomic number and atomic mass? The options are atomic number is 222 and atomic mass is 222 and atomic number is 85. Atomic mass is 230 and 88, 288, 222 and 44. Amazing questions. All right. So let's try to do this now. First of all, okay, this is the element. Now, this element, first of all, if it undergoes radioactive decay and it gives out 2 alpha particles, what will be? So when it releases or when it emits out alpha particles, first thing you have to understand is this, guys. When an alpha particle is being emitted out, the atomic number would reduce by 4, whereas the atomic mass would reduce by 8. This is the first thing you have to understand. So if that is the case, what will happen? So I'll say that Q, which is a brand new element, would be A minus 8 and Z minus 4, because it's losing 4 at 4. The atomic number reduced by 4 and atomic mass reduced by 8. Really sorry for the sound, guys. I know it's been super irritating. It's from morning they start this. So yeah. So plus what? 2, because you're emitting out 2 alpha particles. 2 will be what? 2He4. So this is what you have. That is basically the alpha particles that is emitted out. Now, once again, it is emitting out 1 more beta particle as well. 1 more beta particle. So what happens? So this new element Q, I'll just call it as Q, A minus 8, Z minus 4, is again emitting out 1 beta particle. So when it loses 1 beta particle, the atomic number reduces by 1. The atomic number reduces by 1. But the atomic mass will remain the same. So atomic mass will be the same. Alright, so atomic number will reduce by 1. So here what happens? Again, so Q, A minus 8, the atomic number would remain the same. But Z will become what? Z minus 3. Plus 0, beta minus 1 is your beta particle. So it is emitting out 1 beta particle, and before that it also emitted out 2 alpha particle. Now, this, okay, I'll call this as not Q anymore. I'll call this as R, because that is the final, the final element that you're going to get is nothing but R, right? So I'm going to write this as R because there's nothing else happening. So I'll write it as R. So what did you get? R A minus 8, Z minus 3 is equal to what? This is the final, the element that you have. So it'll be what? R 222 by, the atomic number is nothing but 85. Now guys, solve for A and solve for Z. Alright. So what is it? A minus Z. You have to find out the atomic number. So A minus 8 is equal to 222. So what is A? A is equal to 222 plus 8, which will be what? 230. So the atomic number would be 230. Whereas the atomic mass on the other hand, sorry, this is the atomic mass. The atomic number on the other hand would be Z minus 3 is equal to 85. So Z is equal to 85 plus 3, which will make it 88. So that would be the answer, guys. It's a very, very interesting question. You just need to know the basics and you'll be able to solve the answer. So yes, guys, A, which is the atomic mass, would be 230, whereas Z, which is the atomic number, would be 88. So that's the answer, guys. That will be the answer for this question. Yo, that would be the answer for the very first question. I know I took more than 1 minute. For sure, it took more than 1 minute, but to explain it and to write it down is going to take a little longer, guys. But yes, this is what it is. If you want to get the solution, again, you can download the notes later, so don't worry about it. So this is how you're going to get the answer for this one, right? Moving on to the next question, people. Third question, 2018 board exam, 2-mark question yet again. 2 to 3 minutes in your exam, will do it less than 1. The question is, what are isobars? And give one example of an isobar. An isobar is one where the when you have 2 or more elements with the same mass number, or you can say same atomic mass, same mass number, but different atomic number. All right. So it has same mass number and different atomic number. So that is what is called as an isobar. But different atomic number. So that is what is called as an isobar. You can give several examples. For example, you can give the example of calcium. So calcium's the atomic mass is 40. The same goes with even potassium as well. Potassium's atomic mass is also 40. You can also give the example of argon as well. Argon's atomic mass is also 40. So all these three are examples of it. You see this, that the atomic number of all the three is different, but the mass number of all the three is the same. So this is what is called as an isobar, where it has the same sorry about that, guys. So it has the same mass number, but has different atomic number. Sorry about that. Yeah, lots of dust particles, people. Lots of dust because of the construction work going on. So it's like very irritating. All right, next one, guys. Another question from 2016 board exam, 2-mark question yet again. 2 to 3 minutes in your exams. Will try to do it less than 1. The question is: a radioactive substance is oxidized. Will there be any change in the nature of its radioactivity? Give a reason for your answer. The answer is quite simple, people. The answer is definitely no. Why? Because oxidation is just a chemical change. Alright, oxidation is a chemical change. And in oxidation, what's happening is that there's only the electrons that is taking part in the chemical reaction. Alright, and radioactivity is all about the nucleus itself. So there is no interaction with the nucleus. There is nothing happening to the nucleus at all. The nucleus is still intact. There is nothing happening to the nucleus. So yes, in the sense, no, there will be no change in the radioactivity. The nature of its radioactivity will remain the same, because of the fact that here it's only the electrons that is involved and not the nucleus itself, right? So that is the answer. Radioactivity is a nuclear phenomenon. That's what I'm talking about. So radioactivity radiations are emitted from the nucleus of the radioactive substance. So any physical change like oxidation, or oxidation is a chemical change, but yeah, so it's a chemical change, but yeah, that's a typo mistake, but yeah, you get the point, people. Any chemical or physical change for that matter will not affect the radioactivity, because again, all of that is happening with the interactions between the electrons and not with the nucleus itself. The nucleus is still intact. There's no interaction whatsoever. So that is the answer, guys. Right, people. So let's hit that like button, hit that subscribe button, hit that bell icon, and if you want to have more such amazing sessions, click on the link that is given in the description and enroll into the pro subscription course. Let me tell you what is the importance and why is it so very important right now for all of you guys who are preparing for your exams. Because no matter what is your state right now, either the people who are watching these videos right now, whoever is watching right now, either you have already prepared for the topic and you're looking for revision, or you have not even started and you're scared and you don't know what to do next, or you have done the revision also, you just want to practice more questions, or you might have some doubts. Now, you might fall in any of these 3 categories. No matter what category you fall under, people, we are here to help you guys out. we will give our 100% to make sure that you guys get the best of the best education, the fullest of our support to ensure that you guys give your best in your boards and your pre-boards. So again guys, the link is given in the description to enroll into the Vedantu post subscription course. Let me tell you what is the whole thing about. So because it's a pro subscription model, it's like, you know, your Amazon Prime and Netflix and all that. So you take a 1 month subscription, you can watch how many movies you want. No, so in the same way, guys, you have unlimited live session once you take up the subscription. How many months you take, 1 month, 3 months, it does not matter. So for those many months, you have unlimited live sessions. You can attend how many of the live sessions you want, and all of those sessions will have some amazing questions. And trust me, you'll have a lot of fun as well, because you have an opportunity to interact with the students, with the teachers. So it's a fun filled, you know, knowledge filled session. And yes, there will be quizzes as well, and those quizzes will definitely help you to push yourself to be better every single day. And those quizzes will also give you an opportunity to compete with the rest of the world and see what are your weaknesses and what are your strengths. Because it is, you know, it's not just about it's not just about answering the question fast, but you also understand better, a little bit better about yourself every day, because you have an opportunity to see how good you are in that particular topic, or if that topic is your weakness, you actually understand that as well with the help of these quizzes. And yes guys, all of these live sessions are recorded, so you can watch the recordings whenever you want, and the recordings are such a way that you can take the quiz while watching the replay also. So those are called as interactive replays. While watching the replay also, it's not like some regular replay. You can take the quiz while watching the replay and still check out the leaderboard once, at the end of every session as well. And you can download all the premium content, you can download all the handwritten notes, everything will be with you guys. So again guys, we will give our 100% to make sure that you are getting the best of the best support to ensure your success. And with all of these guys, I would say this is probably the best part of Vedantu, is that you don't have just one teacher to help you guys out, guys. In every live session with the master teacher, you will also have the class teacher to ensure every doubt of yours is cleared inside the class itself. No matter how many number of doubts you have, 100, 200, does not matter. All of your doubts will be cleared inside the class itself. I know that a lot of you guys here right now watching the video has a lot of doubts. Since you're preparing more intensely for your exams, you'll have a lot more doubts, and you're still figuring out like how to get your doubts cleared. Don't worry guys, because those things will also be taken care of. And yes, you will have some amazing tests and assignments, and those tests and assignments, the questions chosen in those tests and assignments are so amazing that they're chosen from past year question papers, from your sample papers. So from the best of the best sources, these questions are chosen. It is tailor-made so that you can be better every single day. With all of these, if you have a lot of time guys, you can attend over 5,000 plus micro courses and crash courses, all for free. So all you have to do is very simple guys. Once you open YouTube right now, I think you guys are already watching the video, obviously that's how you're getting to know about it. But yes, if you let me just show you how to enroll into the this thing. 1 second guys, let me just show you how it really works. So once you open the website, once you open Vedantu, open any of the videos, click on show more, click on subscribe to Vedantu Pro right now. Click on it guys. You can also check out all the playlists over here. Every single playlist will be given, so you can choose any of those playlists and check out all the videos as well. So once you're into the Vedantu website, they'll ask you which grade do you belong to. Let's say you're in 10th grade. They'll ask you which board do you belong to, CBSE, ICSE or Maharashtra. Whatever board you choose, you'll get all these information. It's very open, it's very transparent. You can check out all the teachers who will be teaching. You can check out the results that came in last year in ICSE. It's students getting more than 95%, 97%, 97.8%. Lots and lots of students who ended up scoring more than 90% who studied at Vedantu. So you can check out all those results, and then what you have to do is click on proceed to pay. Now here's the thing is, there is a twist. However, there is a twist. Obviously, it's not a story without a twist, right? So here's the twist, people. For the next couple of days, that the base price of that course you just saw right now is nothing but 2,699. But if you use my coupon code AMEPRO, you get a discount of flat 50%, and what you're paying is exactly the half of the amount, that is 1,349 rupees. So we can say 1,350 rupees. This is what you're going to pay. The coupon code is AMEPRO to avail the discount. Now think about the value of money, guys, because in that 1 month duration, you would have attended a minimum of 200 sessions. That means that per session, each and every session, you're just paying about 6.7 rupees, which is a lot less than a packet of Lays which you spent 5 minutes for, right? It's for your own education. So once you enroll in the courses, guys, you can check out all the upcoming sessions. So this is how it will be. So you can go to my sessions, check out all the upcoming sections, check out all the past sessions. So if you click on replay, you can check out all the replay of that particular session as well. You can download all the notes by clicking on get notes. You can download it in the form of PDF. Everything would be available to you. So this is how it will be. All those notes, everything the teacher has written, all of that can be seen over there. So click on my courses to check out all the courses that you're eligible for. You can enroll to any of these courses because all of these are free. Once you enroll to the pro subscription, everything is yours. So you can check out whichever course you want and enroll into those courses and check out the videos of that as well. Right, guys? So again, the link is given in the description. A lot more is coming your way. Check out the link. The coupon code is AMEPRO to avail 50% discount. With that said, let's get back to the topic. 2018 question, 3 mark, 3 to 5 minutes in your exams. We'll try to do it in less than 2. The question is, the ore of uranium found in nature contains uranium-238 and uranium-235. The atomic mass of document, right? Although both the isotopes are fissionable, it is found out experimentally that one of the isotope is more easily fissionable. Name the isotope of uranium which is easily fissionable. Give a reason for your answer. And give a nuclear reaction when uranium-238 emits an alpha particle to form thorium nucleus. Thorium, yes. Let's go, guys. Come on. It's a very easy question. It's actually a very easy question. The first part of the question is, name the isotope of uranium which is easily fissionable. See, guys, comparing uranium-238 and 235. 235 is actually much more fissionable than 238. Why is that so? Is because, guys, uranium-238 is actually a very stable atom of uranium. It's actually a very stable atom. So if you bombard it with a nucleus, if you bombard it with a proton or a neutron, yes, you will basically you can start seeing radioactive decay. But then uranium-235 is even more unstable. So it's very unstable. Uranium-235 is very unstable. So if you bombard it with a proton or a neutron, you will be getting far more energy, and more importantly, not just in terms of energy, but it's much more easier because it's very unstable. Even that smallest amount of energy can actually yield you, you can start seeing the radioactive decay happening much more faster. So that is why uranium-235 is more fissionable. Why? Because it's more unstable. It's more unstable than that of uranium-238. Third part of the question is, write a nuclear reaction for uranium-238 emitting out alpha particle, right? So uranium-238 the atomic number is 92. So when it undergoes a radioactive decay and it releases an alpha particle, so alpha particle He2 4 would be the alpha particle. So again, subtract the atomic mass by 4 and the atomic number by 2. That is what is thorium. So thorium would be what? TH would be 234, and this will be 90, because 92 minus because here one alpha particle is going away, so you're emitting out the alpha particle. So when an alpha particle is emitted out, the atomic number decreases by 2 and the atomic mass decreases by 4. So that would be the answer for this question. Simple. So that would be the answer, people. That is it. If I'm not wrong, that should be the right answer. It is. So yeah, the answer to this question is that, right? So yeah, because, guys, like I told you, 235 is much more it's much more fissionable because of the fact that it absorbs neutrons and becomes very unstable very quickly. So you can see the radioactive decay happening much more faster in comparison to 238, which is a stabler form of uranium, right? But both of these are used in your nuclear reactors. Both of these are actually used in your nuclear reactors, right? Next question, people. Here's another one. The question is quite a simple one. Now, the question was taken up from 2017 board exam. It's a 3-mark question. 3 to 5 minutes in your exams. We'll try to do it in less than 2. The question is, what are free electrons? Why do they need why do they not leave the metal surface on their own, and how can they be made to leave the metal surface? Now it's a 3-part question, each part carrying 1 mark. So what are free electrons? Are nothing but the electrons which are basically not bound by the nucleus or the force, the nuclear force, and basically are free to move. That is what is called as a free electron. In other words, the electrons that are free to move, the electrons that are free to move about, that are free to move about, free to move about in that metal surface. That is what is called as a free electron, right? Or sometimes we also call it as a valence electron. The electron that is there in the last shell, that is also called as that valence electron, is what then turns up into the free electron when it comes out of the what to say from the when it when you give energy to it, what happens is that it gives it it gets enough energy to break the bond, and basically not the bond is the force, the nuclear force would basically it will exceed the nuclear force and basically come out of the valence shell. So that is what then becomes a free electron. And second part of the question is, why do they not leave the metal surface on their own? The reason why they can't leave the metal surface on their own is because, guys, there is, even though it is free to move about, there are 2 reasons. We can say that one reason is because when these electrons are coming out of its place, basically what's happening is the positive, the positive charges that are there inside the metal surface will try to attack them. Will try to attract them. So the positive charges will try to attract them. So that is one reason. So they have to overcome that force as well. So that is one of the reasons why they can't easily come out. Secondly, once they've come out of the, let's say there's an atom, they come out of the the valence shell. As they are moving, the other atoms in that metal surface could probably attract them. So this is the reason they can't easily leave the metal surface on their own, right? So you can mention both of these reasons are correct to some extent. So you can mention the first one. First one is more appropriate. I would say that because of the fact that when they come out of the prescribed place, the positive charges would try to attract them. The positive charges would try to attract them. That is why they can't come across, because that is again, that force is trying to push the, to keep them in their place. They're not letting them escape. That is why they cannot easily leave on their own. Third part of the question is, how can they be made to leave the metal surface? You can make them leave either by photoelectric effect. That is basically shining a light at a certain frequency. That is one thing, photoelectric effect. Or you can also do thermionic emission. Thermionic emission, where basically you give heat energy to it. So either of these two can be used to basically get the electron out, or emit the electron from the metal surface, right? I know I'm blabbering a lot, guys, because I'm very distracted for this. The sound has been, going on in my head since morning. So I'm like, I'm fumbling a lot today for some reason because of this sound. Like I'm starting to feel, like they're drilling into my head. It feels like that right now. So I'm fumbling a lot because of that. I'm not able to, keep a straight face, and I'm not able to gather my thoughts. I'm fumbling a lot because of that. I'm really sorry for that, case. But yeah, what can be done? Anyways, so yeah, people, that is the answer for this question. There are electrons which are not bound to the nucleus, which are free to move, is what is called the free electron, because again, they are being pulled by the positive charges which are left behind. That is one of the reasons why they can't move out on their own. Third is that they can be left by either thermionic emission or by photoelectric emission. Both of these are the right answers, right? Next is another 2017 question, 3 mark, 3 to 5 minutes in your exams, 2 minutes in your sprint text. Let's try to do it. State 3 factors on which the rate of emission of an electron from a metal surface depends on. State the 3 factors on which the rate of emission of an electron from a metal surface depends on. The first one is, guys, the work function. That is one thing that it depends on, because the lower the work function, the lesser amount of heat energy that you have to give in order to emit the electrons. That is one thing. Second, you can also talk about the surface area of the material. Surface area is also something that it affects. Thirdly, you can also talk about the temperature of the material as well. The temperature also is something that plays a part. So these are the three factors that you can talk about: temperature, the nature of the material, which is nothing but your the work function that I just talked about, and the surface area of the material. All of these are factors that affects the rate of emission of electron. How many number of electrons are emitted in a second? That rate of emission is something that depends on all of these three factors, right? Last question, guys. 2018 board exam again. It's a 4-mark question. 4 to 7 minutes in exam. They can around do it in 4 to 7 minutes. But in your sprint tech, you'll try to do it in less than 2. The question, even though might look humongous, it's actually a very simple question. The question is, radiation given out by us from a source when subject to an electric field in the direction perpendicular to their path are shown in the diagram. So you can see this over here, right? So this is a lead box. You can see the radioactive substances being emitted out. So you have the arrows of the path. The arrows show the path of the radiation A, B, and C. So this is A here, this is B over here, this is C over here. Name the radiation B which is unaffected by the electrostatic field. The one that is unaffected by the electrostatic field would be your gamma rays, right? The gamma rays are the ones which do not get affected by the electric fields. So gamma rays would be the answer for this one. Second part of the question is, why does radiation C deflect more? You see this? Why is the beta particle, so C is nothing but beta particle and A is nothing but the alpha particle. Why is beta particle deflecting more in comparison, much more faster than alpha particle? Is because beta particle is much more heavier than that of alpha particle. In other words, you can say that alpha particle is lighter than beta particle. Because alpha particle is lighter than beta particle would get deflected much more than the alpha particle because it's much more heavier, right? In comparison, beta is much more heavier than alpha because, in other words, alpha is much more heavier. You can see that alpha is much more heavier. So that is one more thing. Next one is, which among the three causes the least biological damage? The one that causes the least biological damage again is the alpha radiations. The alpha radiations are the ones which cause the least biological damage, whereas gamma on the other hand causes the most amount of damage. Name the radiation which is used in carbon dating. The carbon dating, the radiation that is used again, we use actually, I believe we use gamma rays again over there also. Gamma rays is what is used in carbon dating. Now if you, what to say, if you're asked to write the equation for that way, so it's carbon 14 is what we use for this, and the atomic number of carbon is nothing but 6. So basically what happens is that when one gamma particle is not, I don't think it's gamma, I think it's beta particle, not gamma, sorry guys, it's beta particle, right? Not gamma, so it's beta particle, not gamma, it's beta, all right? Beta particle, all right? Sorry for that. So beta particle, once again, so what's happening is that beta is -1 beta. So what's happening is that C14 5. So basically, so you're getting a new what to say, it will not be C anymore, it will be N, right? It will be nitrogen, right? So that's what's going to happen. So yeah, it will be N. So the atomic number reduces by 1 and the mass number remains the same. So yeah, I think that is the answer, guys. Yeah, they have not mentioned over here, but yes. All right, guys. I think I made a mistake in the second part of the question. Why does the radiation deflect more than A? Because it is light. Okay, so yeah, sorry about that, guys. Sorry, I mixed it up a little. Again, I'm really sorry about this. Sorry, because this lot of disturbance, I'm not able to focus. Anyways, why does the radiation C deflect more than A? Is because it is much more lighter than A. So alpha is much more heavier than beta particle, right? So I mixed it up. Sorry, guys. So alpha is much more heavier than beta, and that is why you see that beta particle gets deflected much more than A, right? The alpha particle. Alpha particle is, on the other hand, is much more heavier, right? So that is the answer. That is the answer for the last question. And this would be the equation. Now they might, if they ask you for 5 marks or for 4 marks, I believe it's better to write down the equation also. It's better that you write down the equation. Here they have not mentioned the equation, so this would be the equation, guys. So you can write it down if you want to, and utilize it in your exams, right? And that is the end of today's session, people. I'm really sorry that I was fumbling a lot. Like it's just that I'm not able to talk with all this disturbance going on. I'm really sorry about that, guys. If I've made any mistakes, I'm truly apologize for that, because it's like it's been a complete mess over here for the past couple of days now. Anyway, so this is the chapter radioactivity is done. This is your homework for today, people. 2017 question. The question is, when does the nucleus of an atom tend to be radioactive? Simple question. When does the nucleus of an atom tend to be radioactive? Let me know what is the answer in the comment section. Let's see who gets the answer for the fastest. So that's it, people. We had the previous session that was calorimetry. Today we have completed radioactivity, and by this, Sprintex 10th ICSE is complete. So congratulations on that. We have successfully completed all the chapters, all amazing questions, or that was that were asked in previous years. If you haven't checked out all the videos yet, make sure that you check it out, please, because year in and year out, Sprintex question has been asked in your boards, so and your pre-boards as well. So do check out these questions. There are some amazing questions that will definitely tickle your thoughts and your understanding. So definitely check those out. Thank you for joining, guys. Again, the link to join the subscription course is in the pinned comment section as well as in the description. The coupon code is AME Pro to avail 50% discount, which is valid for the next couple of days. Thank you for joining. Subscribe to the channel, hit that like button, hit the bell icon. See you guys in the next one, people. Thank you. Until the next time, this is Anoop signing off for the day. Have a great evening ahead. Bye bye. See you.